Okay, started over, so there's a couple of things off kilter there with the camera. Still is something, but not gonna worry about it right now. Okay, so we aren't doing a quiz today. We reviewed straight lines. How you graph them, how you interpret the graph, how you get the equation from the graph and all that stuff. So be sure you are in good shape with that. Now I want to hit some more of the high points. Y'all are pretty good with solving. Linear equations. And of course, this is very important. So you can multiply, divide, add, subtract both sides by the same quantity, okay? The word by doesn't really apply universally to all those operations, but you understand what we mean. And you understand that we can't multiply by zero or divide by zero. Division by zero is forbidden, multiplication by zero wipes out all our information, and we never get a solution. Or anything solves an equation once you've multiplied it by zero, because everything gives you zero. Okay. You want to simplify both sides first, generally. If you got denominators, multiply both sides by the common denominator. And I'm going to say something that I'm not going to really test you on, but for the future. Say noting that the value of the multiplier and I should say cannot be zero. I guess I'll go ahead and change that. Cannot be zero. That applies when your denominator is a variable expression. Like your denominator is x minus 3, and you want to multiply both sides by x minus 3. You got to write carefully that x can't equal 3, because that would make x minus 3 0. Now, that's not something you've encountered a lot in the assignments, but it's worth noting for completeness here. Okay. Put all the variables on one side. all non-variable quantities on the other. And that's all I'm saying. We've done numerous examples. You see numerous examples in your textbook. And if you want more examples, ask the internet. You can even go to AI and ask for equations, for a series of linear equations, although I don't necessarily recommend that because I'm not sure AI knows how to solve them. Okay, it'll make up solutions. At least last time I tried to do this, which was a couple of years ago with GPT-3, was making up solutions that had nothing to do with the equations. And I still think it's not real good at actually doing the math. It'll explain it to you, it'll give you the rules, it'll do a good job of that. But you can always find worked examples and so forth if you need them. Okay, that's something we've covered pretty thoroughly. So make sure you know how to solve linear equations. And of course, part of that is being able to solve them to do simultaneous equations. Formulas. Quantity you solve for is considered the variable. Everything else is non-variable. So again, you follow this rule, put all the variables on one side and solve. And, you know, I realize as I say that, I'm going to change my wording here. I say put all variables. When you're talking about a formula, you might have several things that you think might be variables, but only one of them is the thing you're solving for. So I'm going to say put all variable expressions. And I didn't leave myself a lot of room. That right there says all variable expressions on one side and non-variable quantities on the other. So that applies to formulas. Quantity you solve for is considered the variable. So any expression that has a variable in it goes on one side. And then you deal with it. Sometimes you got to factor, sometimes you got to multiply, divide, do all kinds of other things. Okay. For absolute value equations, absolute value of x equals c. X could either be c or negative c. Another thing I'll specify is that c has to be greater than or equal to 0 because the absolute value of something can't be a negative. If c is negative, then this equation has no solution. Now, I don't have a real good notation yet to use for this, not one that you'd be sufficiently familiar with. So I just say absolute value of an expression is equal to C. That expression might be 5x plus 3 or 2x squared minus 4x plus 9. Okay. That breaks into the expression equals C. And I like to put that word or in there because it could be one or the other, could be your solution. Maybe both are solutions. So whatever the expression is, you set it equal to C and then solve. Now, we have inequalities and absolute value inequalities and other types of inequalities. They're just like equations, except when you multiply or divide by a negative quantity, the inequality reverses. Now, when you get to absolute value inequalities, first thing, if the absolute value of x is less than C, then here's x equals negative C, here's x equals C, and here's your solution set. And of course, you've got x equals 0 in the middle of x equals C and x equals negative C. So that's a picture of your inequality, and it should be obvious why that's so. Because x both has to be less than C, but x less than C would go all the way to negative infinity. But x also has to be greater than negative C. So we can say that x, absolute value of x less than C, breaks into two inequalities. X less than C but x less than C isn't enough. If x is less than C, you could have any number on the other side of negative C. So it also has to be greater than negative C. Now, absolute value of x greater than C we can use the same picture. We need to throw x equals 0 in here. But the absolute value of x has to be greater than C. That's not true between here and here, because between negative C and C, the absolute value of x is less than C. anywhere outside this interval, not including, I'm going to do greater than or equal, okay? So back up, either X, the absolute value of X is less than C, or it's greater than or equal to C. Those are the two possibilities. It's one or the other. And those two possibilities don't overlap. If the absolute value of X is less than C, then it sure isn't greater than or equal to C, right? So we can say that, okay, well, then this solution set would consist of everything to the right of C, everything to the left of C, and since we've got a greater than or equal, we include C. So X greater than or equal to C, absolute value of X greater than or equal to C. And I should always say here, C greater than or equal to 0 breaks into X less than negative C or X greater than C. This is an and, it has to be both less than C and greater than negative C. This is an or because it can't be in both places. And that should be a less than or equal, and this should be a greater than or equal. Okay? X can't be here as well as here. But X can be less than C. This X here, and where my finger is less than C, and it's greater than negative C. And over here, again, can't be both, it's or. Now this extends very simply, naturally. I'm abbreviating the word expression, EXPR. Breaks into, just like absolute value, X less than C, breaks into X less than C and X greater than negative C. And didn't put C in here, I put zeros in here, which was not smart. Expression less than C, expression greater than negative C. Okay, whatever's in the absolute value signs has to be between negative C and C. If it's outside that range, it's not, the absolute value is going to be less than C. So there's how it breaks down. And let's make sure, you know, got almost all the board there, but not all of them. I think I got everything now. Okay. So anyhow, so whatever your expression is, it acts just like an absolute value of X, just an absolute value of whatever the expression is. Okay, an absolute value of an expression greater than or equal to C, where C has to be greater than or equal to 0, breaks into whatever that expression is greater than or equal to C or less than or equal to C by the same logic we used for just X. And that's very important. Majority of students who take the midterm in this course get it wrong. They don't do both. You always get two inequalities. Okay, they just take the absolute value signs off, solve it. And I'll give them, you know, a point or two for that. but that's only getting one solution. And there are two solutions, so you want to focus on that idea. That's kind of a big common pitfall. Good for geometry. In this course, we're not concerned with proving geometric theorems. We're concerned with things like finding areas and volumes, perimeters. So that's the main thing. Okay. For a rectangle, okay, let's assume that I've divided this thing up uniformly into squares, and each square is one square unit. So that, for example, pick any one. I'll shade this one here. This is one square unit. This one over here is one square unit. Everyone, assuming I've divided this up better than I really did, is one square unit. So how many square units do we have? Well, we can count them, but the area is the number of square units. And to get that, we multiply how many rows you got by how many are in a row. Now, this is a rectangle. It's length times width, because the length is how many are in a row, and the width is how many rows there are. So the number in a row is your length, and the number of rows is your width. That's fundamental. If you have a rectangular solid, more properly called a rectangular parallelepiped, okay? I didn't draw that quite right. But you get the idea that you have layers by the number in a layer. Does that make sense? And you got a layer here, a layer here, a layer here, a layer here, here, and here. So you got 1, 2, 3, 4, 5, 6 layers in this case. Okay, well. Take a little space here. Number in a layer is a number in a row times the number of rows, which equals the area of the base. Say it's the area of the base layer, which equals length times width. Number of layers corresponds to the height. Got 6 layers here, so think 6 units high. Okay, the volume's the number of cubic units. You can see that this thing would be divided into little cubes, and that's a cubic unit. So that cube could fit into here as one of the cubes. Number of layers times the area of a layer, which is height times length times width. So it's very easy, if you know the height, the length, and the width, to get the volume of a rectangular solid. Okay. Now let's look at a right triangle. Okay, here's a right triangle. And here's an upside down copy. That's a right angle, and this is a right angle. Well, with triangles, we refer to one side as the base, the other side is the altitude. Okay, now that's when you have perpendicular sides. The altitude will be the length of the side perpendicular to the base. Okay, area of the triangle's half the rectangle's area. Area of the rectangle is its length times its width. And for this rectangle, you can take the base to be the length and the altitude to be the width. That just says base multiplied by altitude. So the area is half the rectangle's area, which is 1/2 the base times the altitude. We'll call the base B and the altitude H. And that's the area of the triangle. If you have a parallelogram and two of the sides are parallel, call this side the base. The altitude has to be the distance between the two parallel sides. Here's your altitude. In order to find the area, we have to use the base and the altitude, not the length of this side and the length of this side. If we chop this rectangle or this triangle off here and glue it back on here, so that we reconstructed it like so, and let's say we just kind of smear it out over here to show that it's gone. It's base times altitude. Where the altitude again is the distance between the parallel sides. Say we have a rectangular solid. The volume of the solid is its height times its length times its width. Okay? Oh boy, I don't have anything to write it. I'm gonna write it too small. Let me see if I can do a better job. Okay. I need that right grotesque. Okay, hopefully you can read that. It's just height times length times width. Remember when we did this, it's a number of layers times the area of a layer, right? The area of a layer is the area of the base. So we could have said it's the height times the area of the base. So that's what I've written down here. Volume is height times length times width. That length times width we take as the area of the base. Okay? Now, if I draw a pyramid in here by taking a point on the top, that's just some point on the upper surface, and then I sketch lines down here, you see that we get a pyramid. Does that picture make sense? It's got the same base, but it comes to a point at the top. And now I can shade this thing a little bit. So that looks exactly like one of the Egyptian pyramids, doesn't it? Well, not really. My artistic skills are what they are. You see that this thing is contained inside of this rectangle, right? Or this rectangular solid. It's like in a box. Just think of this rectangular solid as a box. And you form a pyramid using any point on top and the four corners of the base. Okay? And I said area when I meant volume. Pyramid volume is 1/3 the volume of this box. Should be 1/3 the height times the base area. Okay. Now, those kinds of shapes are important, and you see other shapes in your open math. And usually you're given a formula, but you want to have an idea what the formula means. It's a little harder to understand the formula for a circle. The circumference is the distance around it. I let R stand for the radius. And that's pi times the diameter. That's what pi is. Pi is the ratio of the distance around the circle to the distance across it. Ratio of the circumference to the diameter. And the diameter is twice the radius. So the circumference is 2 pi r. And the first thing you got to know about a circle, at least first thing I'm going to tell you about a circle, the first thing you want to understand is this is what pi is. You need to know the definition of pi. Take any circle, no matter how big or how small, measure the distance around it, and measure the distance across it through the middle, in other words, the diameter. And if you divide that circumference by the diameter, you're always going to get pi. Now, if you don't measure completely accurately, you won't get a completely accurate measurement of pi. And, it's a calculation scheme that allows us to calculate it to as many decimal places as our computer will handle. And that's a lot of decimal places, trillions. Okay. And more than that, if we wanted, trillions, maybe not trillions of trillions, I don't know. CPU speed and stuff, I don't want to try to figure that out. I don't really know how many teraflops you get and how many, it's okay. If I knew that, I'd be able to give you an estimate of how many we could generate in a day with a powerful computer, lots of them. Okay, so anyhow, there's what pi is. Kind of important to know that. Also, the area is pi r squared. And I'm not going to give you those formulas. Okay. A couple of things I'll put on the exam to give you a bit of a hint. But on a circle, you're on your own. If you don't know 2 pi r and pi r squared, and notice that these two formulas look almost identical. It's just that you take the 2 here and put it here, and you got this, right? So how can you tell which one's circumference and which one's area? Areas in square units. So you gotta use pi r squared. Okay? Because r is your radius in meters or feet or miles or whatever. R squared will be in square feet or square miles or square whatever. Okay? Areas in square units, you gotta square something. Nothing squared here. That's just gonna be in plain old units of distance. R is in miles, 2 pi times r is in miles. Want to use that common sense. Sphere. Area of the surface is 4 pi r squared, which is the area of 4 circles of the same radius. Okay? Or 4 times the area of a circle of the same radius. Okay? Volume's 4/3 pi r cubed. We have cubic units, so it's r cubed. Now, I would not give you that formula, but I might write 4/3 pi r cubed, 4 pi r squared, 2 pi r, just without telling you what they are. So you should know them, you should memorize them. But you might well see them. To help you jog your memory and get all, the 4/3 pi might be kind of hard to remember. If you got this and this, you remember to multiply this by 4 to get this. But the 4/3 pi r cubed is a little harder to remember, okay? Still, you should remember it. I might ask it without telling you, but I'll probably give you some expressions just to help you out a little bit. Oh, yeah. One more, I'll do a little space right here. Cone. You got a base. It doesn't have to be a circle. If it's not a circle, you probably don't know how to calculate its area. If it's a circle of radius r, then you know how to find its area, right? Now we come up to some point here. It doesn't have to be right above the center. Doesn't matter where it is. It may be a little lopsided. But here's a cone. The altitude is measured perpendicular to the base. I should have done a cylinder first. Well, I'm gonna do a cylinder as well as a cone. So a cylinder just comes up perpendicular to the base. We've got a cone here. And we got a cylinder. Here. You can think of the cone being inside the cylinder, so I'm gonna kind of shade the cylinder and see the cone's kind of caught inside that cylinder now, right? The cylinder area equals the base area times the height. Note that the rectangular solid, I'm using the wrong words and I apologize. Cylinder volume is the base area times the height. Cylinder volume is base area times height. A rectangular solid volume is base area times height, times altitude. I'm kind of using height a little bit loosely. Altitude is the better term. So what do we got here? I hate to flip this around. Hang on a minute. So what I've written is the cone volume is 1/3 of the cylinder volume. Just like the pyramid volume is 1/3 of the volume of that box that contains it. So I'm gonna start out a little quick summary here. Hopefully you can read that length times width times height. But the thing you really might want to remember is it's the area of the base times the height. that's important. Pyramid. I don't know why it's that noisy on the whole. Okay. Want to double check the time, make sure I wasn't going insane. Likely at any moment. Okay, pyramid volume. By height, I really mean altitude that has a specific definition. I'm not going to belabor it right now. By height, I mean the height perpendicular to the base. Cylinder. The volume is the area of the base times the altitude. Again, height isn't quite the right word, but it's easier to abbreviate, okay? As long as you remember that the St. Call height is altitude measured perpendicular to the base, you'll be okay with it. And for a cone, the volume is 1/3 the area of the base times the height. Visualize a pyramid inside a box. Calculate the volume of the box and take 1/3 of that. Imagine a cone inside a cylinder. Find the area of the cylinder. Take 1/3 of that. For these formulas, area of base times altitude works. Okay. No matter whether the pyramid has a rectangular base, parallelogram for a base, or some kind of a polygon for a base. Okay. Whatever the base is, you can multiply the area of the base by the height. And same for cylinder, whatever the base is, it's a circle, the area is going to be pi r squared, okay? It's something else. Again, it's probably something you can't calculate with what you know, but it still works if you know the area of the base, no matter if the base is elliptical or some weird curve, okay? We have this relationship. And then you have the area of a circle, surface area of a sphere, and so forth, and the volume of the sphere. Okay. Now, I went on for a while about geometry, but it's something that people often need in later courses and don't know much about. You probably saw all this stuff earlier in your education, but you probably haven't retained it. I haven't tested to see whether you retained it or not. Okay, if you're like almost all students come out of their high school courses, it's probably true of most of them. Okay. Then we just get back into order of operations and percents and fractions. Okay. So I'll say a little bit about percents. The idea percent is how many per hundred. If it's 15%, then it's 15 per hundred. Imagine you have 100 people in a room, 15 of them would be 15%. And 1,000 of them, of course, you need 10 times more, 150 people. You get a percent of a number, you convert the percent to a decimal and multiply by the number. Not giving you an abbreviated statement of that. You should look at the statement in your text, make sure you understand it and understand how it's applied by the examples. A percent more than a number, find the percent of the number and then add the number. 15% more than 100 people is 15% of 100 people, which is 15 people. Added to 100 people gives you 115 people. Just a couple of basic pointers. You really need to work some more percent problems. Make sure that you're able to work the various types of percent problems. Now I'll mention, and I hope I've been recording. Yeah, I have. Okay, I'll mention that I posted a document and there's a problem bank. It's got like 80, 100 problems on it, but they're in groups. Okay. So you can read down through those groups and see what kind of problems you can expect to see on the test. Make sure you know how to do them. Okay. And there's some that you don't. Some mention polynomials. That was on the test last year, on the midterm last spring, but it won't be on the midterm this spring. Okay, you're going to see that probably as early as next week. So I might even put those problems on the midterm as optional problems. An optional problem is one that you can do without any risk. You work it, and if you do well on it, if you do well enough on it to raise your score, I'll raise your score. If not, I'll just say nice try, good ambition. Okay. But didn't quite get it, and I think you're going to get it next time. Okay. What do you need to know about fractions? Multiply the numerators. And multiply the denominators. then reduce if possible. Okay? Sometimes it isn't possible. And to reduce the fraction, divide the numerator and denominator both by the greatest common factor. I'd like to do an example, but the time doesn't permit it at this point, and we've done many earlier in the course, so you do need to review in your book and other resources. Just look up how to reduce fractions. You'll see more instruction than you can handle. Okay? More instruction than humanity can probably handle. A lot of stuff up there. Okay. Now, I want to talk about adding and subtracting fractions. I don't want to try to squeeze it into this small area. So I am going to flip the board now. Multiplying fractions is real easy. Actually, I should also mention I'm not going to use a lot of terms, just review how you divide fractions. The words come down to invert and multiply. You got to know which one to invert. It's the one after the division sign or the one after the slash. I could give it a name, but people aren't real good with the names. Okay. Add fractions. If they have the same denominator, add the numerators. And keep the same denominator. If different denominators, find a common denominator. Preferably the least common denominator. Multiply each fraction. Not sure exactly how to say this. So I'm gonna modify that just a little bit. I want to get the idea without getting too detailed or technical, to just kind of remind you what you have to do so you can review it. I'm saying multiply the denominator of each fraction by whatever it takes to get the common denominator, and multiply the numerator by the same quantity. If you multiply both the numerator and the denominator by the same quantity, you don't change the value of the fraction. And the way you've seen me do that is just by you multiply by a fraction that has the same numerator and the same denominator. Okay, well, that's pretty much it. And that came out right on the spot on the, last time is up. Okay. So good luck with that review. Let me know if you have questions. I'd be glad to answer them.